Good evening. This is Robert Pulse. How's everybody doing? Let me get things set up here. Okay, there we go. Okay, let me start off by saying if you're coming to this because you're used to my genealogy or my game information, this is a total new line for me. This is going to be a science fiction. It's going to be in the form of a business plan. And I'm calling it right now for our working name is SLC Sub-Lunar Closed Loop Moon Base Service. Okay. So if you have people that are interested in sci-fi, please direct them here. If you're not, I do appreciate you taking and visiting tonight, but you're probably going to not be interested in this if you were looking for genealogy. Okay. So as you all know, I recently spent a stint in the hospital, and while I was there, I started writing. And this is some of the stuff that I wrote. Okay. Now, what we're talking about is a moon-based service, business plan for a moon-based service. And some of the things that this service is going to provide is going to have a solar power plant where individuals can take and charge up their units. It's going to offer four-wheeled articulated bots that can go out and perform science or take and perform surveying, do that. It's going to have a communication satellite service with an AI service in it. It's going to have basically a salvage system that's going to be based on ion propulsion units and grappling hooks and collecting space garbage and bringing it to the moon and reprocessing it at the moon instead of burning it up when it burns up in the atmosphere. So from a recycling perspective, it will be the devices on the moon base will be there to take and recycle those products into usable products. And it's going to feature a tunnel that's going to be 16 feet or 16 meters underneath the moon surface, which gives it a stable habitat for doing science. The temperature was constant, so you know what temperature to take and adjust for. It's going to have a landing pad for landing ships, of course. Well, and the first one's going to have to land on the surface of the moon, but after that, hopefully the equipment on the first ship will take and do it. It's going to offer hotel accommodations for astronauts that are working for other organizations that are working on the moon. So you can come and get your bots charged up. You can take and have a good meal at the hotel accommodations, and then you can go back out and do your work. Okay. It's also going to do spaceship repairs, and it's going to also build spaceships. And there's an advantage to doing that on the moon. Okay. So let's talk about this. This is a collaboration effort. I'm talking to everybody that's viewing this. This is a science fiction. The hope is that the combination of contributors out there and the discussion that occurs, that the ideas will result in something that's a workable solution. I don't claim to be God. I don't know all the details and stuff like that. I was an engineer for a third of my existence in this world, and I still consider myself an engineer, even though I spent time in sales and also in marketing. But I still consider myself an engineer, and I was a reliability engineer, and you're going to see some of that in here. I'm breaking from a traditional sci-fi fiction because I'm writing this as a business plan. And so think of it from that perspective. And I'm also using AI Ernest, my AI Ernest Gemini as one of the collaborators, and keeps me straight when I start doing things that aren't there. Possible videos in this series. There's 11 identified business units right now. Each one of those need to take and be viewed in detail, and it's my plan to take and do a video for each one of those. Based on the feedback that I get on this video, we'll probably determine which one of those will be first. Standard components. A lot of the financing and base product in this video that generates the revenue that it does and the profit margin that it does is based on the fact that they're standard components. So you can't just willy-nilly build something and put it out in space and then expect it to be serviced and have all the inventory there that you need. Stocking keeping units become an issue. Number of tools become an issue. The size of the holes become an issue because you've got to be able to drill them out, and you've got to be able to tap them, and you've got to be able to take them and have tools that pull those bearings out and tools that pull those seals out. See, I told you the reliability engineering was going to start showing up. So I only discuss fasteners and shafts in this discussion today, but it covers everything. It covers microprocessors. It covers the plating on the ships. The ships that arrive that deliver this and in this model will be disassembled and their components will be reused. So reuse, recycle, all that is going to be a major portion of this project. There's also additional businesses that will be identified. For instance, I looked at the massive telescope on the moon. What's the possibility of reaching a stage where that is a product that you sell time on? Don't have enough information to take and start including that yet. But things like that can be done on the moon and do that. But the reason why a telescope on the moon makes sense is that there's no atmosphere to take and distort it. The reason why it doesn't make sense is that it's going to be facing the sun for about half the cycle. But then you can take and study the sun using that telescope. So that has some possibilities there. So I just don't have enough knowledge base right now to take and make that a business unit. Each rollout, I talk about 3 phases already. There'll be at least 3 phases. There'll be a lot more probably. Each phase will take and require a video. Videos basically are like science fiction book chapters. And then, do you have any suggestions for things that ought to be included after you read this today or go through this? Okay. The core vision, the working name right now is SLC, Project SLC, which is going to be financed by a consortium, just like any business on the stock market would be. It converts traditional high-risk lunar exploration model to a highly profitable, self-scaling, heavy industrial utility and a recycling infrastructure business instead of relying on indefinitely on expensive disposable hardware shipped from Earth's deep gravity well. The consortium anchors its operations inside a 16-meter subsurface crater tunnel, utilizing a highly disciplined 3-tier hardware standard and an aggressive orbital space salvage capturing program to achieve a closed-loop, zero-waste space economy. Be interesting if we can do this, right? Sounds really good. The financial health metrics are: initial phase 1 is set up a capital expense is $340 million. It's going to be the tunnel boring machine, which is a key part of that. The telecom installation is going to be actually the first thing. Data centers, CE, and a surface power grid. That's basically phase 1. Matured gross annual revenue, which is after phase 1, I'm closer to after phase 2 is implemented, will be in about $562 million. That total annual base operating expense is expected to be around $84 million. The annual operating profit at this point in time is going to be $472 million. Oops. Ought to be consistent, shouldn't I? And the consolidated net profit margin is 85%. Initial payback time is 1.2 years from activation of the phase 2 commercial streams. And so we now have a business model. It's very tentative. This will shift around all over the place as we go through this. Project SLC, it's a standardized closed-loop blueprint, extraterrestrial industrial infrastructure. Hopefully this blueprint will be sufficient to take and be used by other projects on other planets later on. So the object is to take and find something that works off of extraterrestrial that works and build a business model around it. It's got to make profit. It's not going to be government funded. And so we're doing that. Today we are reviewing the master plan for Project SLC. We're moving away from the paradigm of treating space as an expensive scientific outpost. Instead, we're looking at the moon as a self-sustaining modular utility grid engineered to yield an unprecedented 85% consolidated net profit. Okay. That means it's got to be open to all countries of the world. The core problem and the gravity solution. Logistics costs of escaping Earth is about 11.2 thousand dollars, and launching from the moon is 2.38. Now, launching from the moon, escape velocity, if you're launching a satellite from the moon and you're going out to, for instance, Mars, you save nearly 80% of the fuel costs. Now, that's assuming that you have moon-developed fuel, and it also assumes that you can take and build the satellite on the moon, and that's what we're trying to do. Subsurface anchors are boring a 16-meter deep tunnel that isolates the operations from cosmic radiation, micrometeorites, and extreme surface temperature swings that can go from 120 degrees C to minus 130 degrees C. We'll be capturing some of that heat when it's at 120 degrees C to heat this tunnel, because the tunnel will be minus 20 degrees C if we don't do that. The single greatest barrier to the space economy is the cost of escaping Earth's gravity, which is that's no surprise to you when you look at the size of the boosters that have to take and put stuff into space. So we're going to take advantage of the lower gravity of Mars, the moon. And by placing our manufacturing, data infrastructure, and repair yards 16 meters inside a stable surface environment on the moon, we stabilize operating conditions and gain immediate logistics coverage over the entire lunar regime. So that's what we're trying to do. Okay. There are 11 business units here, 6 of them. We're going to have an interplanetary shipyard. That's going to be like phase 3. We're going to have commercial real estate. Okay. That's where we rent out portions of the tunnel for companies or for companies or possibly countries to take and do it. It says Chamber 2. Chamber 2 is the first one in phase 2 that we'll start renting out. We can rent out more. We can even build, using our boring machine, facilities for other people. We will be deploying satellites that have GPS and also have AI computer centers up there around the moon. Now, in order to use them, you're going to have a contract with us. And so that's what this business is. Salvage operations is the process where we salvage space information. Things like second stages of rockets and stuff of that nature. We put ion propulsion units on them, and we grapple them, and we bring to the vicinity of the moon. And then we have units that bring them down to the moon where we salvage them. And we use those materials then to either make other things. For instance, the obvious thing is that we take the solar panels off that and add it to our solar panel collection. Vehicle maintenance garage. Okay, this is where we repair vehicles for either our own or this money is assuming that we're repairing them for other people. We replace wheels. You know how wheels burned up on Mars. We take and replace seals. We replace all types of things. Now, that's where the having standard components becomes very important, because if you have standard components, the cost will be about 10% of the cost of doing non-standard components. And so that's where the standard component part is in there. Closed loop accommodations. We have hotels. We will be growing food. We have to prove that that can be done, but we will be trying to provide food. We will be like a general store where, you know, like the mountain man used to come to take and get supplies when they were exploring the American West. So we will have supplies there for other countries and stuff. So this will be like a general store. It'll have a hotel where you can rest. It'll have showers where you can take a shower. This will all be inside of that tunnel. You can have your vehicle maintained. In addition to the maintenance, part of the maintenance garage is recharging it. So if your batteries need recharging, if you need to swap out batteries, we have that capability. Like I said, we can replace tires and we can replace seals. The moon's environment is very, very rough on seals around shafts and stuff of that nature. So that's one reason why we want to have standardized parts, is so that we have the seals and bearings and other things to take and replace that. We'll have the tools to pull those out. Okay. Additional businesses, propellant sales. We're going to take polar ice, which this is based on H2O. There is a possibility of H3 on the moon. H3 is a very high potential propellant. And so we will have propellant sales. We will have a licensing process for removing your space junk. Right now, the international bodies are getting very upset with space junk. And so one of the pieces, and it's a $30 million business we're forecasting, is to take and sign licenses with people that are putting up satellites, or people that are putting up second stages that are staying up there, and offering them a license agreement. And that means that we have to go send our ion propulsion units out there, grapple their products, bring it to Mars where we salvage them. It works from our standpoint. It gives us salvage to take and convert into other things. Okay, we have a precision vacuum fabrication lab. That'll be part of the tunnel, and we have to have a contract for that before we actually build it, but that's fine. We will have to have at least one person. Active debris clearance subscriptions. Okay, that's part of the standard license agreement and certification thing. And media and interactive telepresence. That's the internet connection, and that's the IA connection. So that is operative from phase 1 on. So the first phase, we are forecasting we can take and generate around 20 million by selling those services to other people that are servicing the moon, like NASA, like China, and like Japan. Every single business line has baseline to ensure compliance with our strict profit margin of 65%. We set this as a base margin for the thing. High margin digital services like our edge data communities, telecom relay networks, and intelligent property licensing loops bounce out the physical wear and tear of vehicle garage, resulting in an exceptional consolidation and a net profit of $478 million. Now that's after about phase 3. Okay. Closed loop space salvage bomb. This is when we're going to have as the landers as our moon landers are leaving Earth, we will deploy solar powered ion propulsion tugs equipped with a mechanical grappling hook, and they will go out and they will take and grapple on to either second stages or dead satellites and start migrating them towards the moon. Once they're in moon orbit, then we'll go up and grapple them and bring them down and down to the moon, where we'll salvage them. The tugs will anchor to default satellites and extended second stages steering them to the base. And that'll be a zero raw material cost. 100% mass solar arrays, for instance, on these units will be integrated directly into our solar grid. It would be nice to get the space station and get all those solar arrays. Even though they decrease over time, they're still producing electricity. Recertified ultrasonic scanning to build interplanet. What we will do with the rocket motors is we'll recertify them. And we'll have a test stand there to test them with. So as we collect second stages, we will have space motors, that are reliable and everything, and we'll be bringing those in. Now, since they weren't made to take and be reused in this manner, we'll have to do some modifications, and we will be standard parts for connections and stuff of that nature. If the last case, there's nothing that can take and be done with the material will be melted down in solar furnaces, and it'll become raw 3D printing feedstock, so we can make new products out of it. We don't leave debris in orbit. We don't buy raw materials from Earth. With our ion tugs, we harvest floating space equity, defunct satellites, provide our power grids with solar cells, spent rocket engines, and our shipyard flight certified rocket engines at zero material acquisition costs. This completely decouples our business growth from the Earthside supply lines, at least for a period of time. I assume at some point they'll want to sell their spent stages to us. Standardized hardware is basically 3 tiers right now. Like I said, this is only for fasteners and shafts at the moment. We will be expanding this to take and include other components like solar cells. We'd like to have standardized solar cells with standardized electrical connections, so that the jumper cables are all standardized and so on. So the first one is going to be a T30 Torex fastener that we standardize on. It's a 5.5 millimeter shaft. So all the tools like the drills and taps and stuff of that nature for the shafts and these fasteners are all the same. So we don't have to have multiple tools up there to take and support this. And here are the basic stock keeping units. You're going to have ceramic ball bearings. You're going to have 3-part seals. You're going to have external snap rings. Okay. Number 3 will be a T50 Torex fastener, which is 9 millimeters for clearance. And the shafts are going to be rover drive shafts, robotic arms, cargo conveyors. Okay. Hardware is going to be 699 shielded bearings, 18 millimeter OD, 3-part seals, 9 millimeter snap rings. Okay. And then our last fastener, this is our heavy duty drive standard. Right now we're not calling out a fastener for this. If we need one, it will be this size. If heavy duty, it will be this size. So we'll figure out what the T number is for that. And it's 26 millimeters. It's the heavy mining equipment, like the heads on the boring machine. It's going to be crane, the nose cone of flight hoppers. Flight hoppers are basically the nose cone of the ships that are bringing hardware in, then convert into hoppers. And we have a plan for that. We'll take and discuss that in a later date. Hardware is going to be a 6005 tapered roller bearing, have a 42 millimeter OD, 3-part seals. We're going with 3-part seals in all cases because of the damage that the surface of the moon does to things. And then we'll have 26.6 millimeter snap rings to take and hold those in place. Snap rings are having that snap ring standard. You have to have a tool to remove them and remove this material and then put the bearings in and put the seals in. So it's important that those are the same. You can't just go helter skelter out there. Whoops. All righty. Let's see. How do I got a view, normal, view, lights on. Oops. Okay. We went down a closed loop salvage model, 11 projects. 3-tier, we went down through here. Okay, now we're back. 3-tier standardized matrix summary. Achieve minimal stock keeping and support tooling. We compress the mechanical complexity of the entire planetary colony down to standard parts. As an example, are shafts and fasteners, and we just went through by matching shaft diameters directly to bolt clearance. Drill sizes, the same drill bits that prep our structural I-beams are used to cut our bearings and seal housing. Tool head inventory slashed by over 90%. Don't need to have a whole lot of extra tools up there for different size bolts and stuff. Now, we'll be servicing non-standard products, and those products will have to pay for that tooling and pay for that shipping from Earth, or pay for the making of it using, if we have enough materials to do 3D printing of the tools. But one or the other, they will pay for that cost. And once they have paid for that, those tools are ours. So we can offer them a discount on services using that tool again, but the tools are ours. And any inventory that we pick up that they pay for, they can run inventory with us, but they'll have to pay for the inventory costs. Okay, service devices, 100% standard parts. The cost to customer will be 10% of the cost of servicing devices utilizing non-standard parts. In addition, service on non-standard have to added costs transporting the tools and inventory from Earth for repairs, and it'll be marked up by 65% minimum. Note these specialized tools and inventory become the property of the Moon Base consortium, and in this case, even though the customer is charged for transportation and person card. D. Okay. Dual mode universal tool interface. The robot and human tools. Every single base tool must be operable by either an automated robotic workbench arm or a human engineer. Zone 1, the robot chuck. It's standardized. Quick disconnect spline shaft for automated electric or magnetic tool couplers. Zone 2, human utility over the mold. Oversized, high friction knurled T handles engineered for the clumsy pressure spacesuit gloves, so that if a robot's unable to complete a task, a human can come in a pressurized suit and complete the task. That's only on the stuff that's outside of the tunnel. If it's inside of the tunnel, we'll still have to have it for the tools. We'll still have to have this for the tools, but inside the tunnel will be obviously easier on the humans than on the outside. There is extraction systems that we've worked into our inventory, our tool inventory. These are blind hole expansion collet extractors, 3-jaw external pullers, reverse thread left hand extractor screws, and easy outs. These all have to be both robot and human usable. Automatic drives on our higher margins, but humans redundancy protects our capital. Every piece of maintenance tooling, including our delicate internal bearing extractors and seal puncher hooks, feature a dual mode handle. If a robot workbench encounters a software anomaly, a human technician wearing thick spacesuit gloves can grab the exact same tool from the rack and perform the extraction manually. The humans are the backups to the robots. Normally the robots will be doing things, but when they have problems, we'll be there. Okay. Strategic execution and risk mitigations. The overall venture probability of success is 74 to 78%. We can actually get higher than that. The critical trigger phase, 100% of the project's early execution risk is concentrated in the first 10 meters of horizontal drilling into the crater face by the tunnel boring machine. And that's assuming that we have put all of our work together and we can bore into that face 10 meters. If we get in 10 meters, we can seal that off and start doing work. And so that's a critical point. After that, our success evaluation goes up to 80 plus success. So the key is, can we bore into the face of this crater? And the reason why we close the craters, then we don't have to bore down to get down to 16 feet and then across. We can go straight in to it, raise it up if it needs to go up 16 feet, or go down a little bit so that we have 16 feet worth of margin material between us and the outside. And that 16 feet is a honey spot for shielding us from all types of micrometeorites and outgassing and all types of different things. And so it gives us so the environmental shielding, surface placement, this eliminates the micrometeorite risk and reduces the outgassing. If you build something on the surface, you're always going to have micrometeorite risk. Now, we do have surface things. We have the ship building facility on the surface, and we have our solar panels out there on the surface. Everything that's on the surface is subject to micrometeorite risk. The fact that most of our time, our human time, will be spent in the tunnel indicates that they will be protected somewhat. And what we're putting at risk are the robots. We also have our fasteners and shaft are pre-treated with molybdenum. It's a dry film coating, and that'll eliminate cold welding. If you're not familiar with that, when you put things together like we did the space station in space, two mated metal pieces tend to weld to each other, and this is how we protect it, so we can take and recycle stuff. Our risk profile places our probability of hitting operational goals at a remarkable 74 to 78%. That's even with the first 10 feet or 10 meters of the tunnel borings brace that going into the rock face. And it secures our subterranean perimeter. The primary structural mechanical risks are retired, and our path to the 562 million mature annual running rate comes clearer. Of course, that $562 million mature rate is around phase 3. Okay. Please like or subscribe if you wish to receive notifications of future installments of this sci-fi business plan. There will be a separate playlist of videos associated with this effort. When I get through publishing this, I will know what that is. And comments on the plan are gratefully accepted and may be incorporated into future videos. Just stay tuned. Let's see how we can take and do this. Okay. All righty. Let's stop share. Let's end.